All right, so welcome back to the OneClass channel. Again, my name is Joey. I'm going to be your chemistry and math teacher for this session. Specifically, I'm going to focus today on high school math problems. So what we're doing in this session is we're going to go through about 10 questions of math problems. We're going to go over some solutions to these problems. And hopefully through that, we get to understand the concept behind those problems, and that will be able to, you will have your best solutions moving forward, whether or not you're currently studying or if you're studying for a future course. Again, my name is Joey. I'm currently an Ontario school educator with OneClass, and my teachable subjects are chemistry and then soon to be mathematics in the Ontario board as well. So without further ado, let's get started on today's problems. I have about 10 problems. They hover between about grade 8 to about grade 12 math. For tuning from the US is probably from about pre-algebra all the way up to the pre-calculus level. So let's get started on our problems today. All right, so first question is asking us, how do you write 1.5 as a fraction? So very easy problem, and we're going to, you typically find in the pre-algebra course, or in about grade 8 to grade 9 math. So let's look at this problem here. Let me just have my tablet the wrong way here. All right, let's write this as question 1 here. So 1.5 as a fraction. So let's first we would change a decimal into a fraction very, very easily because we can first examine this number. So 1.5 here, we can see that this is in the tens digit. So therefore we can actually create a mixed fraction first. So how do we do that? Well, this to the left of the decimal place is my whole number. So I can say that this here is a 1, and then this 0.5 is going to be 5 over 10, right? Because again, I have this 5 here is going to be my numerator, so whatever is in the decimal is my numerator, and the denominator is simply just because depending on the digit. The denominator depends on the digit where this decimal falls in, and in this case, this is in the tens digits. So this is going to be over 10. So we have 1 and 5/10. So therefore, we can convert this now into an improper fraction. Right now we have a mixed fraction. So we can convert this into an improper fraction. And how do we do that? Well, what we can do is we can simply just take our whole number, multiply by the denominator, and we're going to add the numerator. So what's 1 times 10? 1 times 10 equals 10. Plus 5. So 1 times 10 is 10, plus 5 is 15. So we're going to have 15 as our new numerator, and it's still going to be over our denominator before. So 15 over 10. And then finally, what we can do is we can reduce this fraction, right? We can reduce this into the lowest terms. As you can see, 15 and 10, the greatest common factor between 15 and 10 is going to be 5. So I'm simply dividing 5 on the top and divide 5 on the bottom. So we can get 3 over 2. 15 divided by 5 is 3, and 10 divided by 5 equals 2. So therefore, our fraction is going to be 3 over 2. And this is going to be our answer for this problem. So as you can see, this solution is correct because again, they have 3 over 2, or they can write 1 and 1/2 depending on what fraction they were looking at. In this case here, they don't specify if it was a mixed fraction or an improper fraction. So what we can do, so 3 over 2 here would be a valid answer. So the solution is correct. All right, let me just reload this page. All right, there we go. Let's look at number 2. So it's asking us, what is the equation of the translated function? If the original function is x squared, it has been translated up 9 units up and 4 units to the right to form g of x. So we're looking for the equation of the function. So this is what we're looking at if we were looking at probably a grade, I want to say a grade 10 to 11 kind of problem here, because x squared here, our parent function, is something you learned in the grade 10 course or in a late algebra 1, algebra 2 course. But translations and anything to do with transformations we look at in the grade 11 course or in algebra 2. So it's going to be a problem like this probably would appear in about early grade 11 or late grade 12, or sorry, late grade 10 kind of course here. So what do we have here? We have f of x equals x squared. And this here is called our parent function because all the transformations that we do reflect onto this, or not, I won't use the word reflect, are going to be applied to this this x squared function here. So we have original function x squared. So let's graph x squared first, and we know our parent function x squared. Very easy to graph. This here's 1, this is 1, this here's a 2, this is going to be a 4, and etc. etc. And this here is -1, this here is -2. So I'm going to have something like this. It has to hit 0, 0 somehow. Something like this. So this is going to be f of x equals x squared. And now it's asking us, okay, what is the equation of the translated function if we're moving 9 units up and 4 units to the right? Well, if I move 9 units up, I can think of this point as 0, 0. I'm moving to 0 and 9, and I'm also using 4 units up. So it's going to become our new parabola is going to start at 4 and 9 here. So it's going to be 4 and then all the way up to, it's going to start at 4, which is all the way here, and up to 9, which is going to be up here. So in terms of the equation, how would we figure that out? Well, graphically, we can easily graph this, right? If I had space here, a 9 would kind of exist up here, and I could graph a 4, and then it would be kind of something like this as well. But how do we view that as an equation? Well, what we can do here is we can simply write down our parent function x squared, and we can follow the general form for transformations. And what is that? Well, I'm going to give you the general form. So it's a x minus b squared, or sorry, minus bx minus c squared plus d. And what does this mean? Well, I'm going to show you. So this a here represents a vertical stretch and compression. So these are some types of transformations that we can do with our function. So vertical stretch and compression. B here represents this horizontal stretch and compression, or stretch or compression, sorry. X is simply just our function here. C is going to be our phase shift. So it either moves up or down. And D here is our vertical shift. So it moves, vertical shift is up or down. Phase shift is right to left here. So as you can see, what we're doing here is we have x squared as our parent function. So we can rewrite this as f of x equals x, and then what we can do, we don't have an a value here. It's saying that we're going to move 4 units to the right, and when we're moving something to the right, we're going to move by -4. We're going to move by +4 here. So in this case here, it's going to be minus +4, and then squared. And then what we can do is we're going to translate the function up, right? And as you can see, vertical shift is this d value, so we're going to move up by 1. So we're going to add 9 to it. And we could simplify this by saying f of x is going to equal x minus 4 squared plus 9. And this here is going to be the equation of our function. That's if our original function has been translated 9 units up, as denoted to this, and 4 units to the right. So like so here. And this here is our correct answer for our solution, for our question. So again, this here is the correct solution, which is good. And as you can see, they actually showed you a graph as well. So x minus 4 squared plus 9. So this is the correct solution. I don't know why it keeps giving me a blank question here. Okay. So this is number 3. I don't really see the question here. What is 0.2 into a fraction? Okay. So that's number 3. So what is 0.2 as a fraction? So again, what we can do is we are simply just changing a fraction to a decimal, right? So it's very, very easy, just like the first problem here. So we're given 0.2. And as you can see, this here is the whole number. In this case, the whole number part is 0. So we don't care about, we won't get a mixed fraction in this case because the whole number part is 0. But we have this guy here is in the tens digit again. Here's the tens digit. So what we can do is we can actually write down our fraction here, right? And a fraction is simply just the numerator is whatever is in the decimal. So this here is 2 divided by whatever, which place it's in. In this case, it's in the tens digit. So 2 over 10. And given 2 over 10, what we can do is we can easily reduce this fraction, right? So we're going to reduce this. I see that 2 and 10, the greatest common factor is 2. So we can divide this by 2 and divide this by 2. And we have 2 divided by 2 is 1. 10 divided by 2 here is 5. So our answer here is 1 over 5. So 0.2 is 1 over 5 as a fraction. So 0.2 is 1/5 as a fraction. And that's going to be the correct answer for this problem. So it says here, step conversion of 0.2 as a fraction. So 0.2 equals 2/10, and then they reduce to lowest terms, which is 1 over 5. So the solution here is correct. All right, number 4. Let's see. Number 4. I might have to download this file, so just give me a second just to view this problem a little bit better. Okay. So let's see if f of x equals root x plus 5, and if g of x equals 2x cubed minus 3x, then what is g of f of g of 4? Okay, so this is something you would see probably typically in advanced functions, because you're given, and why I know this is because they're given specific things. So you have root x here, which is a function that you probably would see in a grade 11 course, and it's being transformed. So probably about a grade 11, grade 12 course, or in a algebra 2 or pre-calculus form. But then this concept of composite functions here, so g of f of g, or f of g of x here. In this case here, it's g of f of g of x is something you would probably see in advanced functions. So this idea of what a composite function is. So how do we do a composite function? Well, what we're going to do with this is we're going to basically work from the inside and work our way out. So I'm going to do this in pink here. So we're going to do this operation first, so g at 4, and then we'll do f of g at 4, and then finally g of f at g of 4. So let's do g of 4 first, and that's going to be our first step here. So I'll denote this as 1. So what's g at 4? Well, that's very, very easy. We can just sub in 4 as our x value here. So g at 4 is going to be 2 times 4 cubed minus 3 times 4. This is going to equal 2 times 4 cubed. So 4 cubed, I believe, is 64. Minus 3 times 4 is going to give me 12. So 2 times 64 is going to give me 128. Let me just verify 4 cubed is 64, yeah. 128 minus 12 is going to be 116. I believe 128 minus 12 is 116. So this is going to be the first part of our problem, which is g at 4. Now what we have to do is find what's f of g at 4. Well, I know g at 4 is 116, so I can just find what's f at 116 to get me f of g at 4. So what I can do is I can do number 2. Let's do this in yellow. So what's f of g at 4? Well, this guy here is simply f at 116, right? Because we found out that g of 4 equals 116. So I'm simply just finding what's f of 116 then. And that's also very easy because I can just sub in 116 into my f of x here. So f of x equals root x plus 5. So it's going to be root of x here, which is 116 plus 5. This is going to give me the square root of 116 plus 5 here is 121, which is going to be the square root of 121 is going to give me 11. Let me just double check that. Yes, it's going to give me 11. So that's number 2. So that's f of g at 4, which is going to equal 11. So now what I finally have to do is I have to find, okay, what's g of f at g of 4, right? And this is going to be our last step of the problem here. So what's f, or is it's g of f at 4. g of f of g at 4 is going to equal g of f at 116, which is going to equal, and I know the f of 116, as we solved here, is going to be simply g at 11, right? And this here is g at 11. So what we can do now is we can simply just sub in g at 11 and solve for our problem, right? So g at 11 is going to equal our g of x equals 2x cubed minus 3x here. So I have 2 times 11 cubed minus 3 times 11. 2x cubed minus 3x. 2x cubed minus 3x. That's good. And now what we can do is we can solve for 2 times what's 11 cubed here. So 11 cubed is going to give me 1331. Minus 3 times 11 is going to give me 33. 2 times 1331 is going to be 2662 minus 33. And this is going to be my final answer. It's going to be 2629. And this is my answer for number, this is question 4 for the day. So again, this is just a composite function, right? And this might look daunting in the beginning, but once you peel back and once you realize, oh, it's just a 3-step problem with g at 4 and then f of that number and then g of that number, it's a very, very easy problem. So as you can see, 2629 is the correct answer. And this here is definitely an incomplete solution. I don't know what they were trying to write. Maybe it was cut off or something like that. So solution is incorrect. Correct answer is 2629. I believe that was number 4. Yeah. Okay, number 4. Let's look at number 5. It's asking us what is half of 1 1 cup. So what? Half of 1 1/3 cups. Okay, so what we can do first is we can change this mixed fraction into an improper fraction, right? So I have 1 1/3. This is going to equal, again, if I were to change this to an improper fraction, I'm multiplying the whole number by the denominator, so 1 times 3 plus our numerator. So 1 times 3 is 3, plus 1 is 4. So I'm going to have 4 over 3 here. Cups. And I'm finding, well, okay, what is half of 4 over 3? So I'm given 4 over 3. And what is half of that? I'm going to multiply that by half here. So again, I have 4 over 3 times 1 over 2. I can see that this diagonal, I can divide both sides by 2. So 4 becomes 2, this becomes 1. So therefore I have 2 times 1 here, which is 2, and 3 times 1 here, which is 3. So I'm going to have 2 over 3 here. And this is going to be the correct answer for this problem. So therefore, half of 1 1/3 cup will be 2/3 of a cup. So this here is our correct answer, and as you can see, this solution is correct. Good analysis. Number 5. Next is number 6. Yep, number 6. How do you write 5/6 as a percent? So what we're doing here is we got to look at our fraction here, which is 5/6, and what we can do is we're simply just multiplying by 100 here to get me a percent. Or what we can do is we can actually convert this to decimal, and that might be a little bit easier for us to figure out percent. But in this case, I'm going to give you a decimal and a percent as well, to see that this will be a repeating decimal, or is a repeating decimal, which will make a repeating percent. So I'm going to do a long division here. So I'm going to do 6 divided by 5, and then I'm going to add some zeros here. So I'll add 3 zeros here, maybe 4 zeros. And then I'm going to simply just do long division, right? So 6 goes into 50 8 times. This is 0.8. 8 times 6 is 48. I can subtract that, so 50 minus 40 here is 2. bring down the 0. 6 times what number gives me 20? 6 times 3 gives me 20. And then 20 minus 18 here is just 2. And as you can see, this is going to be repeating again, right? So 6 times 3 will give me 18 minus 2, bring down the 0, bring down 3 again. So this 3 here is definitely a repeating decimal here. And what we can do is we can actually change this to a percent, right? So 0.83 bar multiplied by 100%. So every time I'm multiplying 100, I always have to move the decimal place 2 times, right? So this is going to be 1 time, and this is 2 times. So I'm going to have 83 point, and this 3 is always repeating, right? So it's going to be 3%. And this here is going to be my answer for this problem, 83.33. So the solution here is correct. And as you can see, this is going to be a repeating decimal. What they did here was they actually multiplied 5/6 straight up by 100 to get me directly from the fraction into the percent, which is also a valid answer here. So if I multiply this by percent, you would get 500 over 6, and you would actually have to do the exact long division here to figure out that this here is simply 83.33, but it doesn't matter. Both ways work as well. So this here is approximately 83.33%. So either way works out. They both give us the same answer. So solution here is correct. Let's look at 7. Asking us, if 2x minus 3 times x plus 4 equals -5, then what is x? Number 7, I believe. So I have 2x minus 3 times x plus 4 equals -5. So what we can do here is we can multiply in, right? And what we're doing here, I really don't know what they're doing here. This is, oh, I do know what they're doing here. Okay, so I have 2x minus 3, and then this here is times x plus 4, right? So what I want to do is I want to expand or use distributive property on these two guys first. So this 3 is going to be multiplied by both of these guys here. So I have 2x, and then minus 3 times x will give me minus 3x, and minus 3 times plus 4 is going to be minus 12 here, which will give me -5. 2x minus 3x is simply just -x. Minus 12 equals -5. And then I can simply add 12 to both sides to get x alone, right? So -x equals -5 plus 12. So -x equals -7. Or sorry, +7. And finally, I can divide both sides by -1, right? So this is divided by -1. X is going to give me -7. And this solution here is correct because they got x equals -7 as well. So the solution here is correct. I just don't like how they did this thing here when they should have done distributive property. This doesn't really show distributive property here. I guess actually no, it does, because you have -3 times x and -3 times 4. But I think you can read this a little bit better. But I guess I can see how they couldn't be due to formatting, so that's totally fine. Because they have -3 here. It's going to be multiplied by x, and then -3 times plus 4 here. So that's kind of how you do this problem. So the solution here is correct. Good analysis. All right. So that was 7 here, which is, let me just check here. Yep. Okay, I have, I believe, one or two more problems. Yeah. Given f, or I think I have 3 more problems actually. Given f of x equals 5x squared minus 2x, and g of x is 3x squared plus x minus 4, what is f plus g of x? And as you can see, the solution is not here, incomplete solution, because I cannot see the attachment clearly. So incorrect solution because I can't see I don't see the problem here, or the solution to the problem, sorry. So f of x is going to give me 5x squared minus 2x. And then g of x is going to get me 3x squared plus x minus 4. It's asking what is f plus g of x. Well, f plus g of x is simply, I'm adding f of x and gx together, right? So this is simply just f of x plus g of x together. So simply, this is going to equal 5x squared minus 2x plus 3x squared plus x minus 4. So I'm simply just using, the property where f plus g times of x is equal to f of x plus g of x, and I can simply just collect terms to solve this problem. So 5x squared plus 3x squared is going to give me 8x squared. Minus 2x plus x will give me just simply minus x. And then we're just left with negative 4. So this is our solution here. 8x squared minus x minus 4. Cannot see attached solution. And I guess I'll just write out my solution for this one. So f plus g of x is equal to f of x plus g of x, which is going to equal 5x squared minus 2x plus 3x squared plus x minus 4, which will give me 8x squared minus x minus 4. And this here is our solution for this problem. 8x squared minus x minus 4. So the solution is incorrect because, again, I cannot see the detailed solution attached. Let's look at number 9. It says, consider a regular polygon with 15 sides. Calculate the angle of rotational symmetry for the regular polygon. So let's look at our polygon here. So we have 15 sides in our polygon. And we want to calculate, we want to know the angle of rotational symmetry. Angle of rotational symmetry. So what we can do right now is we can actually visualize this as, it's really hard to visualize a polygon with 15 sides, but you're going to have to, in geometry, what we have to recognize that any polygon, the sum of the interior angles is going to equal 360. So sum of interior angles is simply 360 over n, where n here is going to be my number of angles. So that's kind of our formula for our sum of interior angles in a polygon. And what we can do now is or actually sum of interior angles is n minus 2 times 180 actually. So this is actually not the correct formula, sorry. Interior angles and angles of rotational symmetry are two different things. I mixed that up, my bad. Sum of interior angles is n minus 2. So sorry, let me erase this again. It's n minus 2 times 180. So that's a different formula here. But what they're asking here is angle of rotational symmetry. So I actually messed that up here. And it's asking, how can I rotate my my shape to become a shape that's already been rotated, basically. So in order to think about this, let's think about an easier problem first. And so let's not do 15 sides, because 15 sides is a little bit hard to visualize. Let's do an angle with 3 sides. So a polygon with 3 sides is simply just a triangle, right? This is our very famous triangle here. And we know that in a triangle here, we have 180. We have 180 is 180 degrees in our polygon. But we also have, if we want to rotate it, the angles of freedom here is going to be 360 degrees, right? Because if you think about this triangle, we can rotate it this way to get us this triangle, and then we can rotate it again to get us this triangle here, and then so we basically get 4 triangles here, right? So let me draw this out. So this is our first triangle. We can rotate it to get this triangle. If I rotate it by 180 degrees, I can rotate it again to get this triangle here, and I can rotate it to this triangle here. So again, I get 4 different triangles for these guys here, right? And what we can do here is, as you can see, this here, if the angles here are going to make up 360 degrees, right? Because if I take the interior angle here, here, and here, I have 90 degrees times 4, right? Which is going to give me 360 degrees. And this here is very, very key to how do we rotate these specific angles here. So we're gonna have 360 degrees, and what we can do is we can find out the angle of rotational symmetry on its rotated retains its original position, right? So for a triangle here, we have 360 degrees. We can divide it by the number of sides, which is going to equal 3, and this will give me 120 degrees. So therefore, the angle which I can rotate this point here is from 1 all the way to 120 degrees. So that's the angle of rotational symmetry for a triangle. Now, for a shape with 15 sides, we can simply just apply this formula to this guy here, right? So we have 360 degrees divided by, well, how many sides do we have? A polygon with 15 sides? Well, we have 15 sides in that, right? So n here is going to equal 15. So what's 360 degrees divided by 15? This is going to give me 24 degrees. So that's going to be our angle of symmetry. And as you can see, this solution is correct as well. So therefore, angle of symmetry, or rotational symmetry, sorry, for polygon with 15 sides is 24 degrees. And this here solution here is correct. All right, and I believe this here is the last problem for today, because I only have 10 problems for today. So the ask is, how would you write 40% as a fraction? Might end up a little early today. That's okay. 40% as a fraction. So yeah, very easy. In this case, instead of changing a fraction to percent, we're changing from a percent back to a fraction, right? So we're simply just dividing this number. Instead of multiplying by 100%, we're going to divide by 100% here. So we're going to have 40%. We're going to divide it by 100%. This is going to give me, the percents are going to cancel out. This is going to be 40 over 100. And then what we could do is we can look at this 40 and 100 and take the greatest common factor and divide it to reduce, right? So as you can see, the greatest common factor in this case is 20. But if you don't see that at first, we can actually divide both sides by 10 first. So we can divide this by 10, divide this by 10. We're going to get 4 divided by 10 is 4. 10 divided by 100 divided by 10, sorry, is 10. So we have 4 over 10 here. And these guys are both even numbers. So we can divide by 2 again. And this is going to give me 4 divided by 2 is 2. 10 divided by 2 here is 5. So this is going to be our correct answer. 2 over 5 is 40% as a fraction. So the solution here is correct. Good analysis. So I believe that's my last problem for today. What I'm going to do now is, because I do have a little bit more time, I'm going to see if I can pick up some more problems for us. So just give me a second while I do that. I'm just going to grab some problems for us as well. So let me add more problems to, let me start selecting problems. Maybe we'll do 1 or 2 more for today here. So let's check this problem here. let's do this problem. Let's do let's do this problem as well. So I picked 2 more problems for us here, and we can figure this stuff out as well. So this here will be our new question. I guess this will be question 11 or 1. So let's see the following problem. So we have 150,000 people visited a theme park last year. 15% of the people visited in March and 30% of the people visited in December. How many people visited the park during the rest of the year? Let me just highlight this for us here. So what do we have here? So we have 150,000 people visited a theme park, and we have 15% of the people visited in March and 30% visited in December. So let's write this down, information down. So the total people, or total amount of people, is going to be 150,000 people, right? So that's per the entire year. So we know that 15% of the 150,000 is going to be in March. 15% of total in March. And we know that we have 30% of the people of total in December. So it's asking us how many people visited the park during the rest of the year. Well, I'm assuming the rest of the year is just all the months added up, besides with exception to March and December. So what we can say here is we can actually add these 2 percentages up to get 45. We can subtract that number by 100% to get us the amount of total number of people in the rest of the months. So we can say that it's going to be 100% minus 15% minus 30%, right? Because again, we have 15% of the people in March and 30% of the people in December. So which means this number here, or this expression here, 100% minus 15% minus 30%, will give us the amount of people that visited it in the months that are not March and December. So this is simply 100% minus 45%, which will give me 55%. So this here is 55% of total visited during the rest of the year. So now what we can do is we can solve this problem, right? We have what's 55% of 150,000 people? So I have 55% of 150,000 people. So in order for us to do that, we can multiply it by a decimal or a percent. It doesn't really matter, or a fraction. Either way, it works for us as well. In this case, I'll use a fraction because, as you can see in big numbers here, they actually used a fraction as well. So they have 55. They're changing the percent into a fraction, so it's 55 divided by 100 times 150,000. As you can see, these 2 zeros cancel out, which means these 2 zeros cancel out here. So I'm left with simply 55 times 1500. And this is going to give me a value of 82,500 people. So this here is our solution. So therefore, you can say 82,500 people visited during the rest of the year. During the rest of the year. So that's going to be our solution. As you can see, the solution here is correct. And then finally, let's do this last problem here. So this is a geometry problem, number 2. So we're given this triangle, IJK. So I'm going to redraw this triangle here. So I, J, and K. And JK here is 5 root 3 units here, and ki here is 10 units. So they're asking us, what is the value of sine 30? So this here is sine 30 degrees. So how do we solve this problem? So let's see, what is sine 30 degrees? Well, what we can do is we can actually find sine here is equal to opposite over the adjacent, right? So it's going to be opposite over adjacent. Or you can say it's equal to ij, which is the opposite side, divided by 10 here. And what we don't know is we don't know the length of the side, right? So we have to solve for this length of the side first. So how do we do that? Well, we can use Pythagorean theorem to solve for this side here. So I know that Pythagorean is c squared equals a squared plus b squared. In this case, c squared here is ik squared equals ij squared plus jk squared here. And ik squared, we know it's 10 squared. We don't know ij squared, but we know jk here is 5 root 3 squared, right? So what we can do now is 10 squared is 100 equals ij squared plus 5 root 3. So let me just use my calculator. 5 root 3 squared is going to give me 75. And we can, if we want to know this, we can just simply do 5 squared times 3, which is 25 times 3, which will give me 75. So that's the calculation for that. I can subtract both sides by 75 to give me 25 on this side equals ij squared. We can square root both sides to get ij here is going to equal 5. So as you can see here, we have 5, ij here equals 5, which means sine 30 is going to be opposite over the hypotenuse. So ij over ik, which is 10. So this here is going to be 5 over 10, which will equal 1/2. So sine 30 degrees here, sine 30 is going to give me 1/2. And that's going to be our solution for this problem. And what I can do is I can type that on my calculator as well. And as you can see here, the sine 30 indeed equals 1/2. So this here is our solution. If you wanted to actually avoid using Pythagorean theorem, what we could do is you can actually visualize this this triangle and recognize it's a special triangle. If we have a 30 degrees here, we have a 90 degrees here, this angle must be a 60 degrees. And if we have a if we know our 30-60 triangle here, and we have 10 and root 5 here, we have to know that this here is a 5 here, because if you look at our special triangle initially, if this here was a 60 guy, this here was a 30 guy, this here would be a 2, 1, this here is a 2, root 3, and 1 triangle here. So that's going to be our special triangle for this. And as you can see, if you look at the proportions here, it's simply, this triangle is simply just multiplied by 5, right? So 2 times 5 here is 10, 1 times 5 here is 5, and root 3 times 5 is simply root 5 root 3 here. So you can actually visualize this triangle and use special triangles to figure the solution out. Or if you didn't recognize that we can simply just use Pythagorean to solve for the opposite side and then plug in what we know to solve for this triangle here. So this solution here is correct. So 1/2 is our correct solution. So sine 30 equals 1/2. Good analysis. So with that, that's going to be my last problem of the game. Again, thank you so much for watching the stream. Again, my name is Joey. I stream math on Mondays and chemistry on Wednesdays. And you can catch me on the stream at youtube.com/OneClass. Again, if you want to access those videos, or if you want to access those the future videos there, you can tune in to the live stream at youtube.com/OneClass, or I believe we stream it also on our website at oneclass.com/livestream as well. As always, thank you so much for watching. Stay safe, stay healthy, and have a great day. Take care.